In this video, we'll be diving into Scikit-learn. Scikit-learn is a powerful Python library for machine learning. It's a collection of simple and efficient tools designed for predictive data analysis. Scikit-learn is open source and commercially usable. This means you can freely use it for research, commercial projects, and everything in between. Now, let's look at some core areas within Scikit-learn. First, we have classification. Classification is all about identifying which category an object belongs to. Think about applications like spam detection or image recognition. Next is regression. In contrast to classification, regression focuses on predicting a continuous value attribute associated with an object. Examples include predicting drug response or stock prices. Moving on, we have clustering. Clustering is about automatic grouping of similar objects into sets. Imagine customer segmentation or grouping experimental outcomes. Another important category is dimensionality reduction. This is concerned with reducing the number of variables you are working with. This can be applied to visualization, increasing efficiency, and noise reduction. Reducing dimensions decreases computational complexity and speeds up processing. Then we have model selection. This is crucial for comparing, validating, and choosing parameters for your models. We want to find the best model for our data. We use techniques to improve accuracy via parameter tuning and might use tools like grid search, cross-validation, and metrics. Finally, we have preprocessing. This is a vital step involving feature extraction and normalization. It's about preparing your data for the machine learning algorithms. Applications include transforming input data and handling text. As you can see, Scikit-learn offers a comprehensive suite of tools for a wide range of machine learning tasks. It's a powerful library for anyone working with data analysis and machine learning in Python. We'll explore some of these categories and functionalities in more detail throughout this lecture series. If you are using Jupyter Notebook, you'll often find that Scikit-learn is already pre-installed. However, if you need to install it, the easiest way to install it to run this command directly within your Jupyter Notebook. In this example, we see a series of lines that say requirement already satisfied, followed by the package name and location. It means that Scikit-learn and its necessary dependencies are already installed on your system. Now let's talk about how we actually start using Scikit-learn in our code. Here are some essential import statements that are very common when working with Scikit-learn for machine learning tasks. As you can see, all these lines start with the keyword from followed by Scikit-learn, which is the standard abbreviation and import name for the Scikit-learn library itself. We are essentially pulling in specific modules and functions from within the largest Scikit-learn package. Let's break down each line. Here we are importing from the model selection module within Scikit-learn. Model selection is all about tools for selecting and evaluating models. Specifically, we are importing the train test split function. Train test split is used to divide your dataset into separate training and testing sets. This is a crucial step in machine learning to properly evaluate how well your model generalizes to unseen data. Here we are importing from the Preprocessing module. Preprocessing in Scikit-learn is dedicated to data preparation. We are importing two important classes here, standard scaler and one-hot encoder. Standard scaler is used for standardizing numerical features, scaling them so they have zero mean and unit variance, which can be beneficial for many algorithms. One-hot encoder is for handling categorical features. It converts categorical data into a numerical format that machine learning algorithms can understand. This line is pulling from the linear model module, which contains various linear models. We are importing logistic regression, which is a very popular algorithm used for classification tasks, particularly for binary classification problems. Here we are looking at the ensemble module. We are importing random forest classifier, which is a powerful and versatile ensemble learning method often used for classification problems. This line is from the metrics module. Metrics in Scikit-learn provides functions for evaluating the performance of your machine learning models. We are importing three common evaluation metrics: accuracy score to calculate the accuracy of the model's predictions, confusion matrix to get a table summarizing the performance of a classification model, and classification report, which builds a text report showing the main classification metrics. So these import statements are setting us up with some fundamental tools from Scikit-learn for splitting data, preprocessing features, using example classification models, and evaluating their performance. These are just a few examples, but they represent the typical modules and functionalities you'll frequently encounter when working with Scikit-learn in practice.